Okay, you guys, this is a continuation of our notes. This is our little balancing refresher from ninth grade year. So when we balance an equation, we're going back to this anatomy of a chemical equation, or what does a chemical equation include? We are going to look at the coefficients. So the coefficients are these large numbers in front of the substances. Those are inserted to balance the equation. They don't change what's in the equation. They just change how many of that substance. So if we put that at the end as a subscript, or we put it in parentheses or something, that's going to completely change what we have. So when we're balancing, we're only putting those big numbers out front. Those are called coefficients. So we're used to changing the subscripts. So the subscripts are the little numbers underneath that tell us the number of atoms of each element. The coefficients tell us how many of those. So if we change the coefficient, like we did here, that changes the amount. We have 2 H2Os. If we added that at the end, so if we put it after our oxygen, that actually changes just how many oxygen there are. And now we have hydrogen peroxide. So remember, we talked about the law of definite proportions. And we talked about in a compound, there's a certain amount of each of the elements. And if we change that, we have something new. So putting that as a subscript changes it from water to hydrogen peroxide. Where putting it out front just changes how many waters we have. So we want to be really careful about that in our balancing. So the reason we balance is the law of conservation of mass. And so our ultimate goal is to make sure that we have the same number of elements on the reactant side as we do on the product side. So we're going to follow this 4-step process. So first we're going to count the number of elements on the reactants. And we're going to show our work in the beginning. And then as we get more comfortable with it, you can kind of go to doing it in your head. Next, we're going to count the number of elements on the, this should say products side. And then we're going to add coefficients to balance. We're going to multiply by the coefficient. And then at the very end, this is really important. Anytime we make a change, we need to recount and make sure that we are still staying on track. So let's try this. So I'm going to make a T-table list. I'm going to put reactants on one side, products on the other, and I'm going to kind of split it right here at my yield sign, my arrow. So when I count the reactants, there's no subscript, so I have 1 iron on the reactant side. And I have 2 irons, that subscript goes to my 2 on the product side. And then my oxygen, that subscript goes to my oxygen. So I have 2 on the reactant side and then my 3 on my product side. So right now I can tell I'm not balanced. So I'm going to go in and I'm going to start balancing. And usually I start kind of at the top of my list and work my way down. So I've got 1 iron on the reactant side and 2 on the product side. So I ask myself, 1 times what equals 2? 1 times 2. So I'm going to put a 2 in the coefficient spot, and then that changes everything after it until I get to like a plus sign or something. So now I'm going to change my Fe to 2, and now I have 2 iron on one side and 2 on the other side. Awesome. Now I'm going to go to my oxygen. I've got 2 in the reactants and 3 on the products. Now this is where it gets challenging because I'm thinking I can't turn 2 into 3 by multiplying by a whole number, and we can only have whole number coefficients. So I'm going to find a common multiple. I want to turn both of these oxygen into 6. So 2 times 3 equals 6. So my coefficient is 3. And then when I recount, 3 in my subscript, or 3 in my coefficient times 2 in my subscript, gives me 6 oxygen total. And I'm going to do the thing on the other side too. 3 times 2, so I'm going to put a 2 in my coefficient. Now this, again, is tricky because that 2 changes everything after it. So now I have 2 times 2 of my iron, that's 4. And I have 2 times 3 of my oxygen, that's 6. So now my oxygen are balanced, but I messed up my iron. So now I need to go back one more time, and I need to figure, okay, 2 times what equals 4? 2 times 2. Now, if there's already a number there, like we already put that 2, you're going to take the number that's there times what you were just saying, so 2 times 2, and I'm going to erase that and totally change it to a 4. Okay, so I'm erasing the whole thing, and I'm changing it to a 4. And then I'm going to recount. 4 times 1 gives me 4. So now I've got 4 iron on both sides, 6 oxygen on both sides. I'm balanced. Okay, let's try another one. So I'm going to count. I've got 1 aluminum, 1 hydrogen, and 1 chlorine on my reactant side. And I have 1 aluminum, 3 chlorine, and 2 hydrogen. Notice, you guys, that when I make my list, I've got the list in the same order, aluminum, hydrogen, and chlorine on both sides. So it's easy for me to compare back and forth. They're not necessarily in that order in my equation. That's okay, but this makes it easier. So I'm going to start at the top with my aluminum. I see it's 1 and 1. I don't want to touch it. Okay, I'm going to go to my hydrogen next. And I see 2 hydrogen in the reactants and 1 in the products. So I'm going to multiply my reactants by 2. That changes my hydrogen to 2, which I wanted to do. But it also changes my chlorine to 2, which maybe wasn't super helpful. So let's go back. Now I'm going to look at my chlorine. I've got 2 in the reactants, 3 in the products. Again, I can't turn 2 into 3 with a whole number, so I'm going to find a common multiple of 6. So I'm going to turn this chlorine into 6 by multiplying by 3. There's already a number there, so I'm going to take 2 times 3, and 2 times 3 is 6. So that changes to 6. Now I need to recount. 6 hydrogen and 6 chlorine. That didn't help me at all, did it? Oh, it just messes it up more. So let's go back. Let's do the chlorine on the other side, and then we'll see if we can get hydrogen figured out. So I've got 6 chlorine on the reactants, 3 on the products. So 3 times 2. I'm going to put my 2 here. And then I'm going to recount. Now I have 2 aluminums, and I have 2 times 3 chlorines, which is 6. Okay, so I got my chlorines. Now my hydrogen and aluminum are off. So I'm going to go back to the top and kind of start over. Got 1 aluminum in the reactants, 2 in the products. So I'm going to take 1 times 2, put my 2 as my coefficient, and then I'm going to recount. Now I've got 2 aluminum, and I'm going to do the same thing with my hydrogen. I've got 6 in the reactants, 2 in the products, so 2 times 3. Put a 3 in front of my hydrogen, recount. 3 times 2 is 6, and I'm balanced. So sometimes there's a little bit of back and forth to these. Okay, let's do another one. So this is a situation where you have oxygen in 2 places, and so we want to balance that last. So I'm going to list carbon. I've got 2, hydrogen I have 6, and oxygen I have 2. Okay, and then on the product side, again, I want to list them in the same order so that I can compare across. I have 1 carbon, I have 2 hydrogen, and then my oxygen. I have 2 here, plus 1 more here for a total of 3 oxygen. When I have oxygen in multiple places, I'm going to cross my fingers that it works out at the end, but sometimes it doesn't, but we'll deal with it at the end, okay? So let's do carbon first. So I've got 2 carbon in my reactants and only 1 in my products. So I'm going to multiply my carbon by 2, which changes my carbon to 2 like I wanted, but it also changes my oxygen. So now I have 4 oxygen, plus I still have 1 here. So that's a total of 5 oxygen now. Okay, let's do hydrogen next. I've got 6 in my reactants, 2 in my products. 2 times 3 is my coefficient. And I'm going to recount. So 3 times 2, I have 6 hydrogen. That's what I meant to do. But it also changed my oxygen. So now I've got 3 oxygen here. So I've got 4 plus another 3 for a total of 7. Okay, whew. Now my oxygen. I've got 2 in the reactants and 7 in the products. 2 times no whole numbers gives me 7. So that means I need to find a common multiple. And my common multiple is going to be 14. So I'm going to go ahead and change it to 14. This is going to make some big changes, so follow me here. 2 times 7 is 14, so I'm going to put a 7 in here, and when I recount, that gives me 14. And then I'm going to go to the other side, and I'm going to multiply by 2. 7 times 2 is 14. But remember, my oxygen is in 2 places, so I need to multiply this coefficient by 2 and the other coefficient by 2. So that is going to become 4 and 6, which changes everything. So I've got 4 and 6 now. Now I need to recount everything. So I've got 4 carbons. 4 times 2 is 8 oxygen there, plus another 6 times 1 is 6. So 8 plus 6 gives me 14. That's what I was going for. And then 6 times 2 gives me 12 hydrogen. So essentially I've doubled everything that I had in the product side. So now I need to go back one last. I need to balance my reactant. So 2 times 2 is going to give me 4. So I put 2 as a coefficient. 2 times 2 is 4. Recount 2 times 6 is 12. And I'm good to go. One last scenario is polyatomics. And you can keep the polyatomics together if they appear on both sides of the equation. So when I'm making my list of reactants and products, I'm going to make aluminum. And then since SO4 is on the reactants and in the products, I'm going to list it as one thing. And since it's in parentheses, I've got 3 of those. Calcium. And then again, hydroxide is on both sides, OH. So I'm going to list it as one thing. And it's just going to cut down on the number of elements that you need to balance. And then also, I don't have oxygen in 2 places now. So I've got 1 aluminum on the products, 1 of the SO4s since there's no parentheses, 1 calcium, and 3 hydroxides. So let's start with the aluminum. I've got 2 aluminum on the reactants, 1 on the products. So I'm going to put a 2 in front of my aluminum and then recount. 2 aluminum, 2 times 3 of the hydroxides gives me 6. I'm going to do sulfates next. I've got 3 in the reactants, 1 in the products. So I need to multiply my products by 3. That changes my calcium to 3 and my sulfate to 3. Now I'm going to go to my calcium on the reactant side. I have 1, and on my products I have 3. So I need to multiply by 3. So I've got 3 calcium, and then 3 times 2 of the hydroxides is 6, and I'm balanced. Much easier than breaking it down into sulfur, oxygen, and hydrogen. If you have a blank spot like this one here at the end, just leave it blank. You don't need to put a 1 in there. It's actually wrong to put a 1, so please don't put 1s.